Good morning, Mom. I am Terna Imanes. Today I'm going to discuss the eye and the camera together with my group mates. Here is our learning objectives. First, compare and contrast the basic structure and function of the human eye and camera. Second, explain the principles of geometric optics as applied to the eye and camera, including refraction, reflection, and lens equations. Third, describe the role of different components of the eye, like the cornea, lens, retina, and camera, like lens, aperture, and sensor in image formation. Fourth, describe the differences in light sensitivity and resolution between the human eye and the cameras. And fifth, explain how the mechanism of color vision in the eye differ from the color capture and representation in cameras. First, I am going to discuss what is camera. I know that we are all familiar of camera. So basically, a camera is a device that captures and records visual images. It typically consists of a lens to focus light, an aperture to control the amount of light entering, and a photosensitive sensor or film to capture the image. Modern cameras can be found in various forms, including digital cameras and those integrated into smartphones. They serve the purpose of preserving visual moments by converting light into a reproducible image. Why camera needs lens? A camera needs a lens to focus light and form a sharp image on the photosensitive surface, which could be a digital sensor or film. The lens plays a crucial role in bending and directing incoming light rays, allowing the camera to create a clear and focused representation of the scene being captured. Different lenses provide various perspectives, depths of field, and focal lengths, contributing to the versatility and creative possibilities in photography. In essence, the lens is a fundamental component for image formation in a camera. What is the purpose of aperture in camera? The aperture in a camera serves two primary purposes. First, controlling the amount of light entering the camera and influencing the depth of field in the resulting image. Second, light control. By adjusting the size of the aperture, the photographer can regulate the amount of light reaching the camera sensor or film. A wider aperture allows more light, making it suitable for low light conditions, while a narrower aperture reduces the amount of light useful in bright environments. Depth of field or DOF, it is an aperture also affects the depth of field, which is the range of distance in the image that appears sharp and in focus. A wide aperture produces a shallow depth of field, isolating the subject from the background, while a narrow aperture increases the depth of field, keeping more of the scene in focus. In summary, the aperture in a camera provides control over exposure and creative control over the aesthetic aspects of a photograph by influencing the depth of field. And now, I'm going to discuss what is an eye. It is an organ. I know that we're all familiar with that. It is a complex and intricate organ in the human body that senses light and allows us to see. It works by capturing light rays, which then pass through the cornea and lens to focus on the retina at the back of the eye. The retina contains light-sensitive cells called rods and cones that convert light into electrical signals. These signals are then transmitted to the brain via the optic nerve, where they are interpreted or creating the visual perception we experience. The eye's ability to adjust its focus, adapt to different lighting conditions, and perceive colors contributes to our sense of sight.
There are differences between the eye and the camera. So in terms of how the eye focuses light is interesting because most of the refraction that takes place is not done by the lens itself, but by the aqueous humor, a liquid on top of the lens. Light is refracted when it comes into the eye by this liquid, reflected a little more by the lens, and then a bit more by the vitreous humor, the jelly-like substance that fills the space between the lens and the retina. The lens is critical in forming a sharp image. However, this is one of the most amazing features of the human eye, that it can adjust so quickly when focusing objects at different distances. This process of adjustment is known as accommodation. On the other hand, with a camera, the lens is a fixed local length. If the object distance is changed, the image distance or the distance between the lens and the film is adjusted by moving the lens. This can't be done with the human eye. The image distance, the distance between the lens and the retina, is fixed. If the object distance is changed, example, the eye is trying to focus objects that are at different distances, then the focal length of the eye is adjusted to create a sharp image. This is done by changing the shape of the lens. A muscle known as the ciliary muscle does this job.
This time, I'm going to discuss the parts and the functions of the camera. So there are four parts and functions of a camera. First is the aperture, second is shutter, third is iris diaphragm, lastly is film. When we say aperture, it is an opening in the camera where the lights enter and it is covered by the convex lens. And also, aperture affects the amounts of background blur in a photo. A wider aperture creates a shallow depth of field, which can be used to isolate a subject and create a blurred background. A narrower aperture, on the other hand, increases the depth of field and keeps more of the scene in focus. That is the aperture. Next is the shutter. When we say shutter, it is opens or closes the aperture, where a fast shutter speed freezes motion and is useful for capturing fast-moving subjects, such as sports or wildlife photography. On the other hand, a slow shutter speed allows for longer exposure times, which can be used to create motion blur or capture low light scenes. That is a shutter. Next is iris diaphragm. Iris diaphragm changes the size of the lens. So, when the iris diaphragm is wide open, it allows more light to pass through the lens, resulting in a brighter image. Lastly is film, where this image is recorded in the form of a latent or invisible image. So, many photographers continue to use film for its unique qualities and artistic expression. So those are the parts and the functions of the camera. Parts and the functions of the eye. So first is pupil, next is eyelids, third is iris, and lastly retina. So when we say pupil, it allows the light to enter in the eyes. Where in the camera, the term pupil is often used to refer to the aperture or the opening through which light enters the camera lens. It is similar to the pupil in the human eye, which control the amount of light that enters the eye. Next is the eyelids. So eyelids, it protects and covers the eye. So in the context of camera, the term eyelids is not commonly used. However, there is a concept called shutter curtains that can be loosely compared to eyelids. Next is the iris. In the human eye, iris controls the amount of light entering the eye by adjusting the size of the pupil. That is for the iris. Lastly is the retina. Retina is a vital part of the human eye that plays a crucial role in vision. It is a thin layer of tissue located at the back of the eye, lining the inner surface of the eyeball. So those are the parts and the functions of the eye. So right now we are going to talk about the image form. So in the camera and the eye, it is the upside down, real and smaller than the object. It is because of the presence of the convex lens. In the camera and the corneal lens system of the eye is like that of a convex lens. Remember that when a ray passes through a convex lens, the ray converges and form a real, the upside down and the smaller image from the original. So that is the image form in the camera and the eye. So once again, thank you everyone for listening our topic, and thank you. Goodbye.